we're looking at here, this video is looking at unit conversions. We need to understand how to convert from one unit to another and how to convert from one system to another. So in sections 9.1 through 9.3, we are talking about a variety of units. If I were to ask you, for example, how fast you were going when the last time you drove to school, you might tell me that you were going 30. But what does that mean? It's tough to tell until you give me the units, say miles per hour. Now I understand how fast you're going. It could have been feet per second. It could have been meters per minute. So many varieties there. Without the units, it can be tough to tell. Luckily, we all kind of have the same sense here in Idaho for what units we'll be using. But the world doesn't always follow what Idaho does. So let's take a look at some units here and see if we can better understand what we're looking at. So in 9.1, we look at length. In 9.2, we include area and volume, which is sometimes called capacity. So we'll need to keep that in mind. And in 9.3, we add weight, and they also add temperature calculations, but that's not a unit conversion so much as a formula we'll use. So in class, I often ask, well, what are some of the lengths we know? And we'll often hear inch, we'll hear foot, we will hear mile, and maybe somebody will say kilometer. Maybe somebody, then we always get centimeter, millimeter, and so on. Occasionally, I will hear furlong. So that's not too common. It seems to show up most often in horse racing at this point. Speaking of horses, hands. That's a way to measure a length. It's about 4 inches, but they measure the height of a horse in hands, and so on. And we usually give little shorted notation for each of these. And I won't write all of these down, but you get the idea. Under area, maybe somebody will say square inches or square feet, and it's really any square length would work. So any of these that we have above, we could have square inches, we could have square feet. We might write it SQ instead of the unit with an exponent. So it could be square kilometers, so on. Those are all areas. Maybe there's acres, which if you dealt with any land, you are familiar with that one. There's a metric version of that called hectares, which you could also deal with. Under volume, well, they'll tell me, well, how about cubic length? And so any one of those lengths cubed, we might have inches cubed or feet cubed. We might use CU, so cubic miles. So that's incredibly huge, so we almost never use that. And then I have students say, well, I don't know any others. And I say, well, I bet you do. But you've heard of gallons. And they say, well, yeah, of course. And then oh, you mean cooking. So how about cups and tablespoons and teaspoons, and the dash is actually a specified volume. There are lots of ways to calculate volume. Weight, we've got pounds, of course. I should write that out like I did the others. Got ounces. What we've got, oh, how about fluid ounces? That is a volume. Some other weights will, then they'll often say kilogram, which I have a personal beef with since that's actually a mass, not a weight. But gram, all of those would, the book is counting as a weight, so you should include that here. And they're doing that because gravity is about the same everywhere on the earth. And so they say, well, it's not too much difference. So we'll go ahead and count kilograms and grams as weight, even though they're actually mass. So we've got that to consider. Well, maybe there's a ton. There's also a metric ton. So we have to consider that as well. Temperature we measure in degrees, either Celsius or Fahrenheit. You've probably seen both of those. And there's also Kelvin, which anybody in the sciences will spend time with, quite likely, or the physical sciences more so. So we've got all these units that we need to consider. And luckily, we have on our formula sheet a number of these units with their conversions. So in class, I'll often ask, well, how many inches in a foot? And they'll say 12. How many feet in a yard? And they'll say 3. And therefore, we know there are 36 inches in a yard. And we will know that maybe some will know that there are 5,280 feet in a mile. Not as many know that there is 2.54 centimeters in an inch, but that has been defined. And notice what we're doing is we're converting here from the US customary over to metric. And so that will be a great conversion to go from one system to another in length. We can use that one a fair bit. These others are close, some are rounded. Like 1 mile is 1.6 kilometers, has been rounded a little bit. And so it's not as exact. Getting down to area, we can go from square lengths to other units. But we have all of these in our formula sheet, and you will get to use your formula sheet on the exam. So don't worry too much about that. Remember, capacity is also volume. So keep that in mind as you're going. But we have a number of these conversions built in, as well as down here in the weight. Notice down here at the bottom, we're going from tons to tons. That's the US customary to the metric we talked about. So we do have a number of these conversions. Now, a number of these, like we say, everybody knows. You know there are 12 inches in a foot. But some of these we don't know as well. And it can become really useful, therefore, to do some conversions from one to another and get a little more comfortable with what we're doing. Now let's talk about the metric system for a minute. This is also on your formula sheet, so that will help. We've got these prefixes here: kilo, hecto, deca, perhaps no prefix like meter, that's just the base unit. Then we've got deci, centa, and milla below that. Notice that these down below end in I. And that can help you know if you're smaller than your base unit or larger. So let's use the base unit of meter, since that's what we have here. A decameter is actually 10 meters. And then 100 meters in a hectometer, and 1,000 meters in a kilometer. Notice that that's just adding another 0 onto the end, as if we were moving our decimal to the right with every jump we make. As we work our way down, looks like we're moving our decimal to the left, which we are. It's because we're dividing by 10 for each jump down. And as a matter of fact, there is an option in our book, or a table in our book, that talks about that motion, how you can start with your base unit and see the base unit here. And then for each step to the right, notice up above, they show the arrow moving to the right, and you move your decimal that same distance. If you're going to the left, you move your decimal to the left. So if you had 10 meters, for example, and you wanted decameters, there's a decimal here afterwards. You move it over to the left one, and you have 1 decameter. That can be a really handy way to move within the metric system. If you're just looking at length or just looking at a change in one particular system, you can just move the decimal. Moving from one system to another or looking at those squared units and so on, the math is identical regardless of which system you're in. But let's keep that in mind. We'll play with it a little bit later. We're also given a potential way to remember. Let me get the metric system back up here. A way to remember these units. I know you've got your formula sheet, but if we had, say, our units written from largest to smallest, kilometer, hectometer, decameter, meter, and so on, and we're working our way, you might remember that using a mnemonic, King Henry died Monday drinking chocolate milk. That gives us the K, H, D, M, D, C, M, those prefix letters. To remember the order those come in. With practice, you get really used to it, and so it'll work out just fine either way. But until we're used to that, having a mnemonic or a table like this on the left will really help us to understand how those prefixes in the metric system. The reality is we could use those prefixes in most any system. For example, I could have a dollar. I could have a decadollar or a hectodollar. Or I could have something like a decadollar or a centadollar. Well, look at that. We call that a centa is 1/100th, and we have 1 cent is 1/100th of a dollar. So perhaps some of these things will actually work really well for us to remember. All right, so let's now extend beyond this a little bit. Maybe we need to convert from one system to another, say metric to English or vice versa. And so we've got some conversions here, like this 1 inch equals 2.54 centimeters. Let's see. I wanted to now take a look at something like this problem, where it says use dimensional analysis to convert the quantity to the indicated units. Now, I would like to point out that, kind of thinking a little bit through this, if I had 5 and I multiply that by 1, I get 5. If I have 7 and I multiply that by 1 and that by 1, 7 times 1 times 1 is 7. Notice I can multiply anything by 1, lots of ones, and it will be exactly the same. So that's what we're going to do with this idea of dimensional analysis. We are going to multiply by versions of 1. And those versions of 1 will be the versions that will help us. So let's take a look at this 9 yards we have, and we're converting that to inches. Oh, by the way, I think I don't want the English to metric so much as, well, let me pull up the formula sheet and see if maybe that has some units that can help me out here. So notice that we have in our units, we've got 36 inches equals 1 yard. So that could help us. Or maybe we use the 12 inches as 1 foot. Either way, I think this will help us out. So back to our dimensional analysis here. We've got 9 yards. And this method that I'm going to tell you will always work and always help you calculate what you need. So we saw earlier that 1 yard is 36 inches. And the question really is now, do I multiply or divide by 36? And that's one reason I really like this method, is it helps me know exactly what I need to do. So I'm going to multiply by a version of 1. Now, if those two are equal to each other, then I could put 1 yard divided by 36 inches. And because those are equal, that equals 1. Or I could invert those and say 36 inches equals 1 yard. That too equals 1, because those are equivalent units. It's like 5 divided by 5 is 1. 7 divided by 7 is 1. Well, 1 yard divided by 36 inches is 1. And now, over here in my analysis, I need to pick the right version of these two fractions that will help me. So if I go ahead and put 36 inches on top and 1 yard on the bottom, let's ignore the unit or the numbers for a minute and just look at the units. Yards divided by yards would cancel. That would be 1. And now that those are canceled, I'm left with just inches in the top, which is exactly what I needed for my answer. And so if I use the right version of 1, units will cancel, and I will now know whether I need to multiply or divide, because I multiply by all of the numbers on the top and I divide by all of the numbers on the bottom, and it will give me the answer. So in this case, I have 9 times 36, which is, let's see, 9 times 3 is 27, and 9 times 6 is 54. So that looks like 324 inches. So multiplying 9 times 36, and then of course dividing by 1, but dividing by 1 doesn't really do anything. So that gives me my final value. And I know that I'm multiplying by the 36, not dividing. Let's do some more. Oh, here we've got centimeters to hectometers. And to do that one, I think I'm going to bring up this other table. So right now I've got centimeters. So I'll put that over here, 187.5. And to get to hectometers, which are over here, from centimeters, to go from centimeters to hectometers, I need to move my decimal once, twice, 3 times, 4 times. So I'll take that decimal and move it 1, 2, 3, 4, and fill any blanks with a 0. So 187.5 centimeters equals 0.01875 hectometers. That one isn't too bad at all. Or we could say divide by 10 for each step. So I had 187.5. I'll divide by 10 to get to decimeters. Divide by 10 to get to meters. Divide by 10 to get to decameters. And divide by 10 to get to hectometers. So each one of those steps I needed to divide by 10. And when I do, I will get that final result. That's one nice thing about, again, moving within length in the metric system. Now let's take a look at this one. This one says feet to meters. So I'm going to grab a different table over here. We've got our English to metric units up. Now 6 feet to meters. So I'm starting with 6 feet. And I need to multiply by versions of 1. All right, well, it says right here that 1 foot is 30.48 centimeters. So I could put 1 foot down here and 30.48 centimeters up here. And that will allow the foot units to cancel. And now I need to get to meters. And as it turns out, there are 100 centimeters in 1 meter. And we know that because there are 100 cents in a dollar. That will take care of making sure that we are in the right unit. Centimeters will cancel, and I'm left with just meters in the top, which is what I want. I want the units I want to be all alone in the top and the other units to cancel. Now, sometimes we will have units in the denominator that we want as well, and I'll do one of those in a minute. So right now I need 6 times 30.48. Remember, I multiply by all of the numbers in the top, and I divide by the numbers in the bottom. So 6 times 30.48 divided by 100. I'm going to go ahead and grab my calculator for this. Should have had it out beforehand. 6 times 30.48 divided by 100 gives me 1.8288. And the units are meters. Does it say to round anywhere? It doesn't. My guess is my math lab will ask me to round to the nearest hundredth. So that would be 1.83 meters. I know that because hundredths are the second decimal in, and the number to the right of that is larger than 5. So I will increase the value in the spot I'm looking at and drop the numbers to the right of that, just like we had on our test. All right, now we've got a couple of problems again with length. Let me show you this one, and I want to show this one specifically to you because it talks about baseball, and I know a number of people don't watch baseball. They don't know the terminology. But as it turns out, the game is played on a baseball diamond. And we've got home plate down here at the bottom, and then they'll run to first base, second base, third base, and home. And so they run around this diamond. And a diamond, by definition, has the same length on each side. So this tells me that each length is 26 meters long. Baseball diamond measures 26 meters along each side. So each of these is 26 meters. And then it says if a batter hit 1 home run in a game. Now let's talk a little about that. If they only hit and can only run to first base, and they'll get out if they try to go any further, that's a single. So a single is a hit where they end at first base. A double is a hit where they can run past first base and make it all the way to second base. A triple is, as you might imagine, when they can hit and keep running past second and make it to third base. And a home run is what they call it when somebody hits it and they can run around to all 4 bases. So I'll say fourth base, though we don't call it that. Home plate is where they end up, but that's a home run. So with this question, it says they hit a home run. That means they're going to run all 4 lengths of the field. So 4 times 26. 4 times 6 is 24. Carry the 2. 4 times 2 is 8, plus 2 is 10. So they run 104 meters total. But they asked me how many kilometers did they run. So let's take that 104 meters and we'll go to our dimensional analysis. We know there are 1,000 meters in 1 kilometer. Now, why did I put the meters on the bottom? So that the meters in the top and the meters in the bottom will cancel, and I'll be left with just kilometers or kilometers. And so I've got 104 divided by 1,000, which really, again, you can just move that decimal, and I get that distance. This setup with the train track or herringbone, the boxes there next to each other, however you want to call that, is perfect for making sure we know to multiply or divide by the appropriate numbers. And that gets us right where we need to go. So that's a length problem with also a little introduction to baseball that might help us. Now, maybe we're looking at areas. Same sort of conversion can happen here. Okay, so with this one, we've got 8 square inches to square centimeters. And up here at the top, we have a conversion from inches to square centimeters. So let's start with what they've given me, 8 square inches. And I need to use this conversion. Well, do I multiply or divide by the 6.5? Again, I'm going to look at the units. I have inches squared, and I don't want inches squared at the end. So I'm going to put those on the bottom so that they cancel, and put the other version on the top. So now I've got inches squared in the numerator and inches squared in the denominator. Those will cancel, leaving me with just square centimeters. So I have 8 times 6.5. My calculator, I don't want to think about it too much, I suppose, this morning. That gives me 52 square centimeters. So that is my conversion from square inches to square centimeters. And I knew I needed to multiply because the numbers were both on top. Again, takes me right to it with this dimensional analysis setup. Maybe we've got a volume problem that we need to look at. 121 milliliters, 2 cubic centimeters. So I see up here at the top that 1 cubic centimeter is 1 milliliter. Well, that's easy. I don't even really need to set this out because it's a 1-to-1. My milliliters will cancel, and I will be left with 12 times 1 divided, or 121 times 1 divided by 1 is 121. And notice I use cc. Turns out, now some of you may ride motorcycles, or you may even be involved in calculating medicine dosages where you see cc's. Cubic centimeters are often called cc's. And I share that because it shows up in the homework a little bit. But sometimes we have a 1-to-1 conversion, which makes it super easy. Oh, I did mention that sometimes we'll have multiple units. So let's take a look at that. Remember at the start I said we were going 30 miles per hour. What if we needed to convert that to feet per second? Notice the 2 different ways we can set this up. The one on the left, mph, miles per hour, doesn't help quite as much as the one on the right, which shows I'm dividing feet by second. So let's go ahead and do our dimensional analysis. 30 miles in 1 hour. 30 miles per hour. Now I need feet per second, so let's get a conversion here. Recall that we said 1 mile equals 5,280 feet. You don't have to memorize that. It is on the formula sheet, but I didn't want to pull up the formula sheet again. So let's use that. And I'll put the miles on the bottom so that it cancels with the miles that I already have. And now I have this version of 1 with miles canceling, and I've got feet now. Now I need to take care of those hours. Well, I know that 1 hour is 60 minutes, and I know I need seconds though, and I know that 1 minute is 60 seconds. So let's use those. I have hours on the bottom, so I'm going to put hours on the top to cancel. And Now I'll use the other one as well, and I'll put minutes on top to cancel with the other minutes. And look at what we have here. All these versions of one, but watch the units. Hours are going to cancel. Minutes are going to cancel because I have one on the top and one on the bottom. And notice what I'm left with. Feet on the top and seconds on the bottom, just like we have it set up here. So as long as we end up with our units organized in the same way we need them, we'll be okay. And I multiply by the numbers on the top, and I divide by the numbers on the bottom. And I'm not really going to, in my calculator, plug in the ones, since those don't do anything, really. So I'll have 30 times 5,280, divide by 60, divide by 60, and that gives me 44. So we end up with 44 feet per second. So if you're going 30 miles an hour, you're traveling 44 feet in every second. How long does it take you to read a text message? So how far do you go in that second if you're not looking at the way at where you're driving? 44 feet. Seems like a pretty good distance. Maybe texting while we're driving is not a good idea. Something to think about. Now we know. Well, we knew before, because you're well aware of what's going on in the world. Now here we are shared a couple of formulas. Both of these formulas are on the formula sheet, but one gives me centigrade. These are temperatures. One gives me Celsius. Centigrade and Celsius are both sometimes used for the same system. If I have Fahrenheit, I can plug it in here and end up with Celsius. If I have Celsius and I want Fahrenheit, I can plug Celsius in here and get Fahrenheit. Well, as it turns out, in this particular problem, I have Celsius, and they say, convert the Celsius temperature to the equivalent on the Fahrenheit scale, where F is the degrees in Fahrenheit, C is Celsius. So they gave me Celsius. I want Fahrenheit. That means I need this second formula. So I'll just take that formula and I will write it down as is. And then just like we did in our earlier stuff, we will take this number and we will plug it in and just run an evaluation. We did that on the exam. So F equals 9/5 of my Celsius temperature. And then I will add 32 to it. Remember, PEMDAS says I need to multiply these before I add. So I'll take 51 times 9, divide by 5. And then I'll add 32 to that. And I get a Fahrenheit temperature of 123.8 degrees. That's pretty warm. Quite a difference from 51. That's an amazing difference. And most of the temperatures that we deal with here have that kind of difference to them. I used to know a song that talked about a steaming 45 degrees. 45 degrees doesn't sound like it's all that hot unless you're talking Celsius. So let's do the same sort of conversion here. This is actually in a song from the 80s. So watch what I'll do here. So canceling out, 5 goes into 45 9 times. Now I have 9 times 9. Sometimes that's a faster way to do it. It allows me to work in my head. 9 times 9 is 81. And add 32 to that. And we get 1 plus 2 is 3. 8 plus 3 is 11. We get 113 degrees Fahrenheit is 45 degrees. And now that's not steaming, but it is pretty darn warm. So makes a little bit of sense. Now let's look at this last bit. We're dealing with weight here. We're not going to do a conversion on this one, but we're going to look at this kind of real world problem. Say 6 items were purchased at a grocery store and they weigh 8 kilograms. One of the items is detergent and weighs 518 grams. What is the total weight in kilograms of the other 5 items? So I need to end up in kilograms. Maybe I should convert these grams to kilograms, and then I can do that conversion pretty easily. So if I go back to this table here, 518 grams, to go from grams, now this says meters, but we're replacing all the M's with G's. So I need to get to kilograms from grams. I move the decimal to the left 3 times. Well, right now, the decimal is at the end. Move it 3 times to the left, and I have kilograms. So that tells me that 518 grams is 0.518 kilograms. And now we come back to our problem. We've got 8 kilograms. One of the items is 0.518 kilograms. What is the weight of the others? So I'll just subtract that 0.518 from that, and I get 7.482 kilograms for the remaining 5 items. Notice they told me in the problem what units I needed at the end. And so keeping that in mind will really help. Now I know that I need to convert things into that unit, so it's easier to calculate. So play around with these and remember that dimensional analysis where we're creating this train track and multiplying by versions of 1 will always get us to the units we need and will allow us to know whether we need to multiply or divide. With this 518 grams, I could have noticed that, well, 1,000 grams is 1 kilogram. And now the grams will cancel, and I'm left with kilograms. And 518 divided by 1,000 is 0.518. I actually prefer that to this method up here where we just move the decimal, because I am most comfortable with this dimensional analysis. I highly recommend you get comfortable with it too, as it will really make sure you get the answers right. Hopefully this helped with some of the dimensional analysis and some of the work we'll be doing. Let me know if you need help. Have a great day.